Nice having all of you here. My name is Scott Davis. I'm going to be talking about Node.js here. So before we get too far, let me put out this award so you all know who you're dealing with here, right? I want any gruff from any of you. I'm an award-winning presenter here. No, that's a wonderful honor. Oh, thank you very much. I really do appreciate it. It is really a joy. That really is an honor. That means an awful lot to me. That will definitely go up in my office among the most important things I have. One of my first visits here, I got a little statue of Ganesha with a laptop. So this will go next to Ganesha with a laptop, okay? So what we are here to talk about this in the next hour or so here is Node.js. Now, we're here on Web Day and on Mobile Day, and you know that I spend a lot of my time dealing with web development. I started as a Java developer. Now, I shouldn't say that. I actually started as a Microsoft developer. I've got 15 Microsoft certifications. And I've spent a lot of time doing web development, reading Marty Hall's book on JSPs and servlets, and Jason Hunter's book, the Copper Kettle book, and Bruce Tate's book, Bitter Java, Bitter EJB, and Better, Faster, Lighter. So many good web technologies out there throughout the years. I spent quite a bit of time talking about Groovy and Grails. And I continue to do Groovy and Grails development. But for the past several years, I have been focusing on HTML5, specifically mobile HTML5, work on tablets and smartphones and smart TVs. And so I came to Node.js fairly late. Now, Node still isn't 1.0 yet, so there's still plenty of time, and it's definitely ready for production. But I ignored Node.js for quite some time because I thought, well, I already know Apache as a web server, and I already know Tomcat as a web server, and I already know Jetty as a web server, and I even have used IIS once or twice before. I don't need another web server in my life. So while everyone is getting really excited about Node, I kind of let it sit off to one side. My eureka moment, my revelation, was that Node.js is not a web server. Node.js is a JavaScript runtime. It allows you to run JavaScript outside of the browser. And what that means is not only can you use it as an app server, as a web server, like everyone traditionally talks about when it comes to Node.js, but you can also use it to run command line scripts. And as a matter of fact, if any of you were in my Modern Web Developers Toolkit workshop, you see that I started talking about Node. Even if you are not going to do a lick of deployment to Node.js, it's still a very interesting technology that can bring you a lot of enhanced capabilities, even if you never use it in production. So what we're going to talk about this afternoon is Node.js, yes, for server-side use, but more importantly, for client-side use as well. And what we really want to understand is the whole Node.js ecosystem. And you cannot learn Node.js without discussing NPM as well, the Node Package Manager. So we have a lot of ground to cover in the next hour or so. But this is where we're going. We will certainly refer to Node.js as a server, but I want you to think that it's certainly more than that. So, let's begin. If you went to the Node.js website right now, nodejs.org, you would see this. And what's really interesting is that very first line, the lead, what they start with is they don't say Node.js is a web server. They say Node.js is a platform built on Chrome's JavaScript runtime. How many of you in here are Java developers? Yeah. My eureka moment, my revelation, was that Node.js is essentially the JDK. We could say that Java is a platform that certainly allows you to serve up web pages, but you can also use Java to manipulate XML. You can also use Java to do file I/O. You can do Java, a lot of things like that. Java is a platform. Of course, all the .NET folks out here know that the CLR is a platform that allows you to do all those kinds of things on there. So Node.js is much closer to the CLR or the JDK than it is Tomcat or IIS. Yeah? Let's spend a little bit more time making sure we really understand this concept, because this is crucial. Beginning web developers will look at a browser and say, oh, that's Internet Explorer. Or, oh, that's Chrome, or that's Firefox. Advanced web developers will look at a browser and say, I wonder what render kit they're using, and I wonder what JavaScript engine they're using. So what I want to do is I want to take us beyond the brand name, the can, and I want to focus more on the fizzy soda that's going inside of it. Because in some cases, as we can see with Safari and Chrome, they're both using the same render kit. Now, before I get too far, let's make sure we are really understanding what's going on. A web browser is essentially three components. Now, I only talk about two of the three up here. But a web browser is a render kit. That's what handles all your HTML and CSS. The second thing a web browser is a JavaScript runtime. That's obviously what executes your JavaScript. The third thing a browser is a plugin infrastructure. That's where your Flash plugin comes in, or your Java plugin, your QuickTime, or so on and so forth. But leaving plugins out of the story for right now, looking at a browser and looking at it as a render kit and a JavaScript engine really helps you answer the questions you need to answer as a professional web developer. So when we look at Chrome, Chrome uses WebKit for its render kit to render the HTML, and it uses V8 for its JavaScript engine. Now, Safari uses WebKit as well. What's interesting is it started as an open source project. It came out of the Konqueror browser, Konqueror with a K, KHTML. And Apple grabbed that project and ran with it. And they were the lead for quite some time. Google came to them later in the party, but Google actually surpassed Apple in terms of the number of commits to that project. So if you were to go and download WebKit right now, you would see commits from both Apple and Google, and as well as a number of open source developers. Google recently announced that they're forking WebKit and they're going in a different direction. Does anyone know what the new WebKit, the new render kit's going to be called? Blink. Exactly. So I'm going to have to go back and update my slides. Blink isn't shipping in production yet, but once it is, I'll update my slides. So what's interesting about this is Opera, a very good company, but very small company, said we are going to stop developing our own render kit, Presto. And we're going to move to WebKit as well. Now, they made that announcement, and it was hugely controversial. And then Google made their announcement that we're going off of WebKit to Blink. And then Opera said, oh, did we say WebKit? We really meant Blink. We're going to Blink too. That's what we're going to do. Blink. Blink's what I meant to say. Yeah, Blink, yeah. So what this means then is in the coming months, we're going to have some really interesting players out there. There will continue to be WebKit. There'll be Blink. There will be Gecko, of course, which is what Firefox has used since the very beginning, and Microsoft's is Trident. But the reason why this is so important, these different render kits, is this is the whole reason that jQuery exists. Marty Hall gave a presentation earlier today on jQuery. And if every browser used the same render kit, jQuery wouldn't exist. Or it might exist in a greatly simplified form, maybe just to ease AJAX calls or things like that. But the whole point of jQuery is to help us deal with the different capabilities, the different render characteristics of a browser. So what jQuery is meant to do is to give us a common API that we can program to. And it polymorphically adapts itself to whatever render kit it's on. Does that make sense? Yeah. Render kits are a really, really important thing for us to be aware of. In the mobile space, both Safari and Android and mobile Chrome both use WebKit. The BlackBerry uses WebKit. The Kindle Fire uses WebKit. So what you begin finding is even though there are a variety of different mobile devices floating around, when they all use the same render engine, it dramatically simplifies our job as developers. Have you heard of a library called Zepto? Z-E-P-T-O, Zepto.js? Yeah. Why are you using Zepto, just out of curiosity? What's the context? You're absolutely right. Just to summarize what you said here, it is API compatible with jQuery. Zepto has the same API as jQuery, but it's targeted at mobile devices. jQuery weighs in at about 200K. Those are round numbers, but roughly 200K. Zepto weighs in at 4K. You know what the difference is? Zepto only deals with WebKit. Just as you were saying, Zepto does not deal with IE, but what you meant to say was Trident, right? Yeah. And it doesn't deal with Firefox, but what you meant to say is Gecko. Yeah. And it'll be really interesting to see what Zepto does when Blink comes out. Will that be the second one that they're coming in? But the delta between 4K and 200K is about what it takes to manage all those different render kits out there. Now, I'm spending a lot of time talking about render kits. We should be talking about JavaScript, right? There are a number of different JavaScript engines out there. You'll see V8 is what Chrome uses. Oh, yeah. Node.js is V8. Node.js is the exact JavaScript engine you would normally be running inside of Chrome, except it's running headless. It's running outside of the browser. So all of a sudden now, you can run all of your unit tests in Node.js and know that you're running on the same JavaScript engine that you would normally get in Chrome. Yeah? You can plug that then into Cruise Control or Hudson or Jenkins. You can do a whole bunch of things in a server environment being able to run this headless that you wouldn't be able to do otherwise. Now, this doesn't excuse you. You'll still need to run unit tests against Nitro and SpiderMonkey and these other JavaScript engines as well. But it's helpful knowing that V8, which is generally recognized as one of the best JavaScript engines out there, one of the fastest, one of the best engineers, it came out of Google. It's really helpful knowing that you can run that as your app server. And we're going to spend the rest of our time talking about Node, but just briefly, I wanted to mention that there's another library out there that you should be aware of. It's called PhantomJS. And PhantomJS is Headless Webkit. It has a whole JavaScript API as well. Now, that might seem kind of weird because that render kit is what normally visually displays what we're trying to see. And so it might seem weird that we would have a browser that doesn't actually display anything. But you can see we can run that headless against all of our unit tests as well. And knowing that it's WebKit means that you'll know that this is going to be a good proxy for testing in Chrome, Safari, mobile Chrome, Kindle Fire, all of those various things like that as well. So being able to run these things headless is really, by headless, of course, outside of the browser, brings some interesting capabilities to the party. But in the spirit of talking about Node, this is from Node's website as well, Node is being used in a variety of different places. Cloud9 is an actual IDE written in JavaScript. If you're a Java developer, you're used to dealing with Eclipse, which is a Java IDE written in Java. You might also be familiar with IntelliJ. That's my Java IDE of choice. IntelliJ is a Java IDE written in Java. I'm assuming that Visual Studio is written in .NET, is written in C#, it's written in something like that. But again, you're using your own language. We like saying you're eating your own dog food. And so if you're a JavaScript developer, using something like Cloud9 is really nice. Cloud9 is an IDE that's written in JavaScript. Of course, once it's in JavaScript, we could run it remotely on a server somewhere, and you get all of the control space, autocomplete, and the accordion, and the directory tree on the side, all those kinds of things. But you can also run it locally, and if you're going to run it locally, you'll probably have Node installed. Now, the good folks at eBay are using Node for a very different reason. They said that we're in a high concurrency environment. Obviously, eBay is in the business of auctions. And so they've got a lot of traffic coming in. Node.js does an incredible job in a high concurrency environment, which is kind of ironic because JavaScript is actually a single-threaded language. There aren't multiple threads in JavaScript. Everything is done by callbacks. But it is so efficient and so optimized that in many micro benchmarks, Node.js outruns Apache and Tomcat and IAS and Jetty and all these other things, even though they're all multi-threaded servers. So eBay is using it for its concurrency. Yahoo is using Node.js to assemble all of its YUI dependencies. If you're familiar with the YUI, the Yahoo UI toolkit, it's a whole bunch of widgets. And so you can say, well, I want to include this widget and that widget and the other. And there are a bunch of combinations. So when that request comes in, there's a Node.js service that's saying, has someone already requested that combination? If they have, I'll serve up that cache combination of all those widgets. If not, I'll generate it based on that request and send it downstream to them. Those three cases, none of them have to do with rendering your web at all. They're ways of using Node.js as a utility behind the scenes. The last case really emphasizes that as well, Voxer. Voxer is a startup, but they do a lot of voice over IP kinds of things. And so Voxer was using Node.js because they have a bunch of APIs, and those APIs are fundamentally JSON-based. And JSON, of course, is JavaScript object notation. So they said, rather than having a Java-based server trying to serve up JavaScript, which you can do, or having a .NET-based web server serve up JavaScript, they wanted to have a JavaScript-based server serve up JavaScript. And so even though it's not the same JavaScript engine, it might be IE, which is running Chakra, and Node, which is running V8, you're still using the same language back and forth. So as developers, you get a lot of language unity. So these are 4 popular use cases. A number of very good books out there. Learning Node, Node Up and Running are both O'Reilly books. I'm an O'Reilly author. I still think they write some of the best books out there. Node.js in Action is a very good one because one of the co-authors is TJ Holloway-Chuck. And TJ Holloway-Chuck is a major player in the Node.js community. He's the guy behind Express, which is a web framework that runs on Node. He's the guy behind Mocha, which is a testing framework. Jade, which is an HTML templating library. A lot of players out there. So he is deeply aware of what's going on in the Node community. So I'm looking forward to his book getting out finally and getting a chance to read that. Now, Node really does run across all platforms. If you've dealt with open source in the past, typically what happens is it runs really well on Linux. And if you're lucky, it runs really well on OS X as well, because that's all just Unix under the covers. It's FreeBSD. But Windows, yeah, not so much. That was the case with Apache. The Apache 1X series was rated for production on Unix-like systems, not for Windows. Apache 2 you can run on Windows safely. You wouldn't have any problems with it. Microsoft recognized this, and they said, we want to make sure Node.js is a first-class citizen on Windows. So they have contributed an enormous amount of code to make sure that it is at feature parity and at stability on par with the other operating systems. So what's especially nice is we can run Node.js across Windows, OS X, or Linux, and know that you've got great feature parity across all of them. As a Java developer, you're familiar with this phrase, aren't you? And I am kind of stealing it from the good folks at Oracle, Sun Microsystems, who coined it, and applying it to JavaScript. Because while Java runs perfectly well across all desktops, can you run Java on an iPhone? Can you run Java on an iPad? No. You can run it on a BlackBerry, of course. You can run it on Android devices. But Java's write once, run anywhere begins to fall down when we get into the mobile space. Can you run Java on your smart TVs? No. Yeah, but you can with JavaScript. So when I look at JavaScript and its reach, I've got 100% coverage across all the desktop platforms. I've got 100% coverage across all the mobile platforms. I can use JavaScript to do Flash scripting and PDF scripting, OpenOffice scripting. I can use it to do smart TV development, Box development, Apple TV, Google TV development. So JavaScript really is the right once run anywhere language. My apologies to Oracle for stealing their catchphrase. This has become my technology stack of choice, Node.js and CouchDB. And what's really nice is that's JavaScript all the way up. So CouchDB is a NoSQL data store that stores its information as pure JSON. I use JavaScript as my query language for my MapReduce queries. I use HTTP GET requests to get data out of it. HTTP puts to update. HTTP deletes to delete. So as a web developer, using JavaScript in my database, in my server, and in my client. As a web developer, using HTTP to access my server and my database really helps me kind of unify my technology stack. A big fan of this stack. So, let's talk a bit about Node.js for server-side use, since that's the traditional way, but then we'll get an opportunity to dig into the client-side stuff as well. It'll be fun seeing JavaScript do file access, which is something you obviously can't do in a browser. But for server-side use, we can end up looking at something like this. Now, the most important line that I want you to focus on right now is that require line, that require HTTP. HTTP is a library, it's a package, it's a module. But this is analogous in Java land to importing java.net.http. Once you import that package, you can begin using it. Notice the very next line, we go ahead and we create a server. Now, web servers, by their very nature, are asynchronous. You spin it up, and then it's just hanging out there waiting for that request to come in. So when that request does come in, this anonymous function is what's going to catch that request. And there's the request and response, and it's going to write those things out accordingly. Now, what's nice about this example is that this pattern can be broken up and used in a variety of different ways. So if I come in, I'm sure it's staring me right in the face. There it was. I was looking for server. It was well hidden right in there. That's why I couldn't find it. Let's see here. I knew I'd find it. If I just kept clicking on random things, it would come up eventually. I wanted to just show you in here that in this example, I've separated that request handler out. This can be a freestanding function right in here, and then when I go to create that server, I can just handle that request handler in. So in many of the examples you'll see online, you'll see these kinds of anonymous functions being passed around in here. But what you have to realize is that functions are first-class citizens in JavaScript. You know, we've been waiting for lambdas in Java for quite some time. Lambdas will hit in Java sometime between Java 8 and Java 22. But we've got that right now in JavaScript, being able to have a free-floating function that has all this functionality and then just drop it in when we need it. So that is why people say, oh, look, Node.js is this wonderfully simple little web server, because you see how easy it is to stand up a web server. Could you do the same kind of thing in Java? Oh, absolutely. Yeah, we could probably do it. It might be a few extra lines of code, but in Java, we could import the HTTP library, we could spin up a new server, we could handle the requests and responses. Now, of course, we don't typically do that. Servlets do a wonderful job of encapsulating that, and web frameworks do a wonderful job of encapsulating this. So you will very rarely do this kind of raw HTTP work. You'll start looking for web frameworks, things like Express, that encapsulate this. But when they say, look how easy it is to spin up a web server, that's helpful. It's also helpful knowing that you aren't tied to the web. They have a more generic library, the net library, And we can see at this point when we require net, we're bringing that in, and we're listening just on raw server ports at this point. Part of what I was doing at Time Warner Cable, doing things, are your television and your cable set-top box are talking about you behind your back. Have you heard of DLNA at all, the Digital Living Network Alliance, DLNA? Have you heard of UP&P, Universal Plug and Play? Yeah, both of those are UDP technologies. Your TV and your set-top box are sending out UDP packets on the wire saying, hi, I'm a set-top box. Hi, I'm a TV. Oh, we ought to get together and show some pixels to our end user. He likes it when we do that. Right? So when we were at Time Warner, we had to do a lot with UDP packets. And so being able to do it in Java, of course I did it in Groovy, but being able to do it in Node.js as well, being able to get at those low-level packets are really a powerful capability of Node.js. But I really do want to come back to this client-side use because there's some really deeply interesting things that you can do. And especially when we start thinking about using JavaScript outside of the browser, it's really going to open your eyes and you're going to see a lot of really interesting things we can do with that. So just like as a Java developer, you would be reaching out for the JDK to see what packages are available to you. In our case, we can go and we can read the Node documentation, and the Node documentation has a series of packages of modules that we can deal with. So we've got a file system module, we've got an events module, we've got HTTP and HTTPS, but we even have some low-level operating system things that we can begin playing around with. So for instance, if I require in the OS library, I can start making calls like, what's the type? What's the platform I'm on? Who's the vendor? What was the release? Good things like that. Again, just to show you, I should have a file here. Here it is. Here's os.js. So we can see what that's doing. It's just reaching out and trying to figure out what platform we're on, what architecture, good things like that. So if I turn around and I say Node, I can see that's the output. Right? This would be no different than us saying Java. But it says, well, I'm sorry, I don't understand what you're talking about there. So we're going to say Node and get that output. So while that stuff is technically correct, the first time I ran this, I said, wait a second, Darwin? Wait a second, 12.2? Those aren't the version numbers I was expecting. I was expecting something like OS 10 or Lion or Snow Leopard or something like that. When I come up here and I say about my Mac, I was expecting version 10.8 to come up, not 12.3. And just to show you, I was equally disappointed when I ran this on Windows 7 and it came back and said Windows NT. So what? I said, wait a second, I'm on Windows 7. How come you're telling me you're on 6.1. Whatever over there? So while these are not technically incorrect, these are the responses you're getting from some lower level Unix libraries like Uname, getting those things out. If we wanted to do something a little bit more sophisticated, we might end up using a different set of client-side libraries. On the Mac, there's a command line utility called swvers that does exactly what you'd expect it to do. Give me the software version of the various things. All right, now we're getting a little bit closer to what I was expecting to see. And on Windows, I would run system info, and that would give me Windows 7 Professional and so on and so forth, service pack level, all this good stuff. So what I can begin doing is I immediately started thinking, well, how would I solve this in Groovy? How would I solve this in Java? There have to be analogs in JavaScript. And so I started saying, okay, well, I'm going to bring in the operating system and the system, child processes as well. Even though JavaScript is single-threaded, V8 is written in C. V8 can spin up however threads I want. And so I can turn around and use the child processes exec method to spin up new threads. Okay, now I also started thinking, well, I'm going to want to be able to shell out and run those different command line utilities. And I'm probably going to want to switch case on these kinds of things. So when you look at this code and realize that when I end up with Darwin, what I really want to do is shell out and run this. And if I'm on Windows, what I really want to do is shell out and run this. And then otherwise, I want to go ahead and use the native Node.js stuff that we would have out of there. Does this source code scare anyone at all? It should feel very familiar to you. Switch cases and, breaks and all those kinds of things like that. But what it allows me to do is begin doing these kinds of things. And notice that I am not in a browser anywhere at all. Now, my browser has different capabilities as well. If I come in and start doing things, I can start doing things like navigator.vendor, navigator.version. Is it version? No, clearly it's not. App version. There we go. So these are the kinds of things I would do in JavaScript when I'm in a browser, determining what my browser vendor is, what my browser version is, good things like that. It's really nice that I can be doing these same kinds of things, testing on what operating system I'm running on. So I could turn around now and have a single app that I deploy across multiple platforms and have it adapt itself, be self-aware enough that it can change based on the platform it's running on. Kind of cool. Kind of cool. So what else? Well, what we want to begin doing now is begin reaching out to third-party libraries. Java has such a rich set of APIs that ship standard with the JDK, but where would our life be without Ant, without JUnit, without Hibernate, without the ability to bring in a bunch of external libraries? And this is where Node.js has in spades. The NPM, the Node Package Manager, is the most easy way to begin adding new libraries in. Now I say that, and I'm not going to demonstrate it to you because obviously it requires an internet connection in order to do these kinds of things. But if you were to go out to nodejs.org right now, you would find, when I checked earlier this week, it was just under 30,000 packages available. I like saying Node.js is kind of like punk rock. Anyone with a free GitHub account feels like they're a Node.js expert. So part of what's nice about Node.js as well is it gives you a lot of metadata about individual packages. As I begin showing you some of these packages we're going to use, one of the first things I do, there's no way I can tell the value of all 30,000 products out there, all 30,000 modules. So the things I will start doing is I'll start looking at the author. Do I recognize the author? Is it a TJ Halachuk? Is it a Burke? Is it someone who's a player in the community? It tells me how many times it's been downloaded. Has it been downloaded tens of thousands of times, or has it been downloaded twice? Once by the author and once by the author's mother. Yeah? So these are the kinds of things that are very helpful when it comes to installing new packages. So NPM was written by a guy named Isaac Schluter. Now, this guy, Ryan Dahl, is the inventor of Node.js. And he was with the project for about 3 years, and he's actually stepped down he didn't enjoy getting up and doing what I'm doing, talking in front of people saying, Node.js is the coolest thing ever. So he said, I'm going to step down. I'm going to focus on more heads down programmery kind of things. And so look who he's turned the reins over to. The guy behind NPM. So once again, I feel like the language, the platform is in very good hands. Except this is his Twitter homepage right there. I guess we need to be a little bit afraid, don't we? But he's definitely a smart guy. In order for NPM to work, the Node Package Manager to work, there is one crucial file that needs to be included, and that's package.json. This is a manifest file that contains all the basic things you'd hope about a given package. The name, the version, the description, the author, the testing commands, fine, good, what repository it's in. But it really is there to explicitly define the dependencies of your project. And not just dependencies, but developer dependencies and production dependencies as well. This is the number one thing I miss when I go back to Java. Because in Java, there's no one single file in your app that has all of these dependencies. Now, different frameworks will fill in that gap and do it, but core Java itself doesn't have anything that says, all right, here are all my dependencies in a single place. You have that with Node.js, package.json. And as a matter of fact, this file has gotten so popular that many non-Node.js libraries have a package JSON as well. If you go and look in the root of the jQuery repository up on GitHub, there's a package.json file there, even though jQuery has nothing to do with Node.js. If you look at Backbone.js, if you look at AngularJS, if you look at _JS, if you look at Ember.js, if you look at Knockout.js, all of these major JavaScript libraries that you're dealing with have a package JSON in the root directory to capture all of this metadata. If you leave forgetting everything else I've said here, I hope you remember the value of this package JSON. Because if you come and join me later this afternoon when I talk about Require.js, Node.js is server-side technology. Require.js is client-side technology. But what file does it require as well? Package.json. This is one you need to pay attention to. There's a great website out there called Nodejitsu.com. Not jujitsu, but Nodejitsu. And if you go out there and take a look at Jitsu, the website right there, they've got a really nice interactive guide. One more thing, the only reason package.json works together so nicely is that it uses something called semver, or semantic versioning. Now, semver is something that we've all used kind of informally through the years. All semver is 3 dotted decimals. It is the major version, the minor version, and the patch level. So we are used to saying that, hey, what version of jQuery are you using? Oh, I just downloaded 1.7.8. I heard 2.0 came out, but I'm going to wait till 2.0.1 comes out. That way they'll have all the bugs fixed. Right? Package.json is fundamentally predicated on semver having exactly 3 digits, and each one of those digits means exactly what it means. So what we'll find here is when you declare your version up here, you've got your version number in there. But when you go into package.json and you start using it to declare your dependencies, so here's test 2. You can see I've got my dependencies defined in here as well. I have a developer dependency of Connect, which is the web server I'm using. I have a developer dependency of JS Hint. That's my linting tool that I have. And then I'm using Volo to deal with my client-side dependencies. And we can see that I've got jQuery and Slang and Volo test as well. Now I can start doing some interesting things with this semantic versioning. By having this kind of tilde here, this is saying, you know what I really care about is 2.7. Yeah, any patch level I want. I typically don't use this syntax. I typically use this syntax. That says exactly the same thing. All 3 decimals have to be in place, but you can wildcard them accordingly. So if I wanted to, I could do something like that. I probably wouldn't. I probably wouldn't much care about patch versions, but would want to at least standardize on a min and major version. But I can explicitly declare it, or I can even use tildes. When I don't use versions like in Slang and Volotest, and by seeing that I'm on the master branch, I'm implicitly saying, I just want the latest version as well. So even by not including a version, you're including a version. You're just saying, give me the latest. But with jQuery, you can see I've pegged myself to this exact version of the library. Make sense? Excellent. Excellent, excellent. All right. Well, this package file, this package JSON is so critical that NPM that we use to install these different libraries, NPM install this, NPM install that, also gives you an init command that basically gives you a nice wizard and carries you through step by step. There is no reason not to have a package JSON in your file. Now here's a package JSON, but let me go ahead and remove it just so I can turn around and recreate it. So I don't have a package JSON, but if I came in here and I said npm init, it says, hey, I'm going to walk through creating a package JSON file. And from that point forward, here up top so you can see it. What's the name of my project? Gids demo. What version am I in? I'm in 0.1.2. What's the description? What's my entry point? If you name the file server.js, then we could just type in npm start. So I'm going to go ahead and do that. What's the command that I use to test this? It might be something like mocha test all. What Git repository is it in? Well, it's in GitHub, Scott Davis 99, some repo. What are the keywords associated with it? Who's the author? What license do I have? Does everything look okay there? If it does, why did it holler? Let's find out. Oh, I must have screwed up the, let's go through this again real quickly. All right, so here it is, Gids demo. Here it is, version 0.1.2. Entry point, test command. Wow, it's really not happy, is it? Okay. Well, don't use this utility. It's not very good. Nah, it's really good. I don't know why it's erroring out on me in here, but I'm sorry? Oh, should I be able to sudo? Yeah, was that what I was yelling at? Maybe it was a permission issue. That's a good point. Yeah, I could definitely do that. But the idea here is you're able to answer a bunch of questions like that. What you end up with on the other end is a well-formed package JSON. It is most likely a permissions issue or something like that. So we could go back and fix that at some point. So how do we turn around and begin running these things? Now, you saw me out of the command line just typing in node to run those things. So once again, if I had a file that had a simple hello world in it somewhere, I could certainly run it. There's my OS.js right there, and so I could say node like that. When you have a server, though, one of the things you might want is for it to, come up, listen on a particular port, do a bunch of things like that. So I could type in node server.js. Really? Oh, well, okay. I can explain that one. I think. There we go. Yep, had a server running on a different port. So we've got this thing up and running right now just by running node. But what's nice is the NPM package manager gives me some generic ways to manage that. If I just type in npm start, it'll fire up the server as well. And what's nice is in any node package I'm dealing with, I don't need to know if they called it index or server or this, that, or the other. I can just type in npm start, and that's a generic way to manage that. npm allows you to add whatever scripts you want in there, and there's a nice scripting block as well. So in my case, if I wanted to lint my code, this is code I anded. It's going to run JS hint and point there. But what this means is I can type in npm lint. And get my code out that way. So the combination between Node and NPM is really close. If you are running Node and you just want to run an arbitrary script, that's fine. But if you're running a more involved server, you'll almost always use the npm command to start that. So since I had a file named server.js, I just accepted the default. But if I wanted to, I could go in and I could be explicit and say, no, when you type in npm start, this is what I want you to type in. So all of a sudden, Node is not just a development environment and an app server. It begins offering a really compelling scripting environment that goes along with it. This is where you can start building all your admin scripts, all your build scripts, all your test scripts, good things like that. So, getting back to this notion of modules now, I've got another module, the file system module. And so if I were to require that and include that, I could turn around and read my directory very simply. Now, there are a couple of interesting things going on with that. One of the things I begin dealing with is a magic variable. Node has a number of double underscore variables, and that defaults to the current directory where the script is executing. But what's more interesting about that is this read dir command. This is the directory I want to read, and then this is the callback handler. Because as you can imagine, dealing with file I/O, that's an asynchronous event. It could take a long time to go out there. So when you see code lumped together like this, it's easy to think that this is a synchronous event. And as a Java developer, Java's a synchronous programming language. As a C# developer, it's a synchronous programming language. This is going to be the number one thing that's going to catch you as you're writing JavaScript, is you're going to expect this code to run synchronously when in fact everything in Node.js is asynchronous. So I am calling the read dir method, and then I have my anonymous function event handler that if there's an error, this will get populated, otherwise I'll have files. And so if I have an error, great, I'll go ahead and spit out that error. Otherwise, I'll go ahead and log out those files. So executing this, all of a sudden I can have JavaScript reaching out, creating directories, deleting directories, renaming files, copying files, moving files, all of that kind of good stuff out there. The file system package has all of the things you would expect to see out of Java I/O file as well. Different syntax, but same capabilities. And while that file system package is nice, there are third-party libraries out there that bring extra things to the party. So I found this little library called Find It. And remember when I said it's got some interesting metadata associated with it. It tells us exactly what we need to do to install it, npm install find it. It tells me how long it's been downloaded. It tells me the maintainer. It tells me the version. It tells me the keywords. It tells me the repository. This website, of course, is just everything that's there in package.json. But I can't tell you how reassuring it is seeing an author, seeing an email address, seeing dependencies, seeing version numbers, seeing all those things right up front. How many times have you stumbled across a jar in your webinf lib directory and said, where did this come from? Has anyone seen this jar? I don't know where this thing came from. So having all of your dependencies be explicitly declared makes a huge difference. Now, if I just typed in npm install find it, it would reach out over the web, download those bits, and drop it in a specific directory called node modules. Once again, these are typically the things we would expect a web framework to provide for us. In Grails, we have a Grails app directory. In our Grails app directory, we have a domain directory and a servers directory and a services directory and all kinds of things. In Node.js, we have a node modules directory. And if we go looking in there, I can see all of my node modules. And if I go looking in there, I see, package.json. So coming over here now so we can see this, node, connect, package.json. I see exactly what version of this library I'm dealing with, the keywords associated with it, the repo, so I know where to reach out for it, the author, remember that guy I mentioned earlier? Yeah, TJ Holloway Chuck. But here are all the dependencies. When I type in npm install connect, npm is going to look in this package JSON and it's going to pull down all of the dependencies. And each one of those has a package JSON and it has those transitive dependencies in place. So npm is bulletproof when it comes to dependency management. And did you notice that in package JSON we had to use semver in there? So it is entirely possible to have multiple versions of the library in your app. These libraries, these modules, don't get loaded up into the global namespace. That's in browser land. We are now in a private namespace situation. Everywhere you will require that thing, you are pulling in that particular version of the library for that particular module. So all of a sudden, I could have 2 or 3 or 4 different versions of the library. I couldn't use all 4 versions in the same function, but when would I want to do that anyway? What it does mean is if I'm using version 2.5 of this foo library, and I pull in someone else and they're using 2.4, and I pull in someone else and they're using 3.1, none of those break my app, which is huge, which is absolutely huge. So, if I type in npm install find it, it's going to pull in find it and all of its dependencies. If I say npm install find it -- save, it's going to write that entry back out to my package JSON. So I don't have to hand edit that. As a matter of fact, after I created that first time with my keywords and things like that, I never hand edit that file. I npm install -- save. I do npm version to rev that version number. I can do all of that through scripting, so I let my code manage my code, which is really helpful. So this is what find it would end up showing up in package JSON as. And then all of a sudden, I can begin writing code that looks like this. And if there was any doubt in your mind that JavaScript was event-driven, this code should dissuade you from that, right? That when I turn around and require find it, and I call the find method with that dir name, the current directory I'm in, that's that single line of execution. all of those on methods, on directory, on file, on link, on end, those are all custom events that the Finder library, the Finder module is throwing. In Java land, you would be throwing exceptions, except exceptions are outrageously expensive. You would never want to do a try catch and have that catch be a part of your normal flow of execution, right? Not in Java. You'd never want that. Although in JavaScript, you absolutely will spin up your own events and you will throw them and you will react to them accordingly. Now, what you have to realize is you can't create your own custom events in the browser. You can't create your own custom events in the browser, but you can in Node.js. And so much so that Node.js is beginning to influence Brendan Eich, the father of JavaScript. Many of the things that we're seeing happen in Node.js right now are making it back into the core library and will end up making it back into the browser. This whole notion of modules. JavaScript doesn't have modules, but Node.js does. And if you come and see me later this afternoon in my Require.js talk, you'll get a much better understanding of how modules behave in Node.js on the server side using CommonJS, how they behave on the client side using AMD, asynchronous module definition, and how they're going to behave in ECMAScript 6 when it finally ships. But in the meantime, this is an awful lot like what your JavaScript is going to look like 5 years from now. In browser, you're going to start throwing your own custom events, catching them, and doing the appropriate thing. Does that make sense? Yeah. Good. Good, good, good. And so if we ran that, we would, of course, get file output out of this. So we have covered a lot of ground here in Node.js. But I hope what you leave understanding is that Node.js is not just a web server. It does do web server jobs very nicely. But that's not the only thing that it does. There are so many things you can do when you have a JavaScript runtime available to you from the command line. You can start doing file I/O. You can start doing operating system introspection. You can start doing process work. You can start sniffing UDP packets. There are so many different things you can do. And what you begin realizing is JavaScript is not the toy language we once thought it would. And when you look at the WARA capabilities of JavaScript, when you look at JavaScript not only running across all desktops, but across all mobile devices, across all smart TVs, and across all app servers and databases and things like that. Because this JSON stuff isn't just coming out of CouchDB, it's coming out of MongoDB, it's coming out of Cassandra. Even recent versions of Oracle can emit JSON as well. But once you start standardizing on a language like JavaScript and are able to use it in the client and use it on the server and use it in the app server and use it in the database server and use it in a variety of different ways, you begin really recognizing the power of JavaScript. Did you have a good time? I did. Thank you so much for your time and attention. I appreciate it.